All right, so a complete oversight on my part. I forgot to give you a homework number 6. That's one of my dogs barking. I'm sure you're very, very disappointed that I forgot to do that. So what I'm going to do is give every one of you credit for homework number 6. And we will begin lesson 7 here with the pregame stretch, which we already did, which you can get off of. I say we already did because we as a class would have done it by now. You can get it off of Moodle. You would have done it already. And then these are the answers to the pregame stretch. Here you go. Remember, you can just do stop and start on the page. So I'm going to pause it for about 5 seconds, then scroll up. We're not in a give and take situation, but if you have any questions, you can email me, talk to a classmate, etc. Okay, so there are all of the correct answers to the pregame stretch. Next up is the slideshow. So let me do that right now. And I'm going to do through slide number 15. And then we got new stuff, and I'll start a new video then. Linear equations in 2 variables, lesson 7. What we have as our agenda for today is homework review, which of course we skipped because I forgot to give you a homework assignment. The pregame stretch, which we just went over. Then now we're into the recent work recap. In other words, the review. And I just want to remind you that after this lesson, we're going to have a pretest and then a test. And you will really appreciate the fact that we spent so much time going over previous work. It means that you're really not going to have to knock yourself out when you study for your upcoming test, okay? The pretest will look very similar to exactly what we've been doing. And I also want to mention that the pretest always looks very much like the test with the numbers change. I do not give you the same exact questions. I just think that's wrong. But I do give you very similar questions. So if you prep the pretest hard, you should do really well on the test. Okay, next, equations in 2 variables. Algebraic solutions is the new material for today, and that'll be the content of the next video. Point of emphasis, the word from. From always goes first. So again, this is review. Let's have you solve these 3 questions. Go ahead. Okay. Of course, we're always doing stop and start, even if I don't mention it every time. The first one is n minus 5 because it's from a number, so from goes first, so the number has to go first. Next up, from 19, so 19 has to go first. And the next one is subtracted from 3 times the square of a number, so 3 times the square of a number has to go first. Okay. The next point of emphasis is the word sum. Let's have you try these 2 questions. Of course, you're doing stop and start, so you can just pause the video. Okay. So the first one says twice the sum of 7 and a number, twice the sum. So first you have to find the sum, which is n plus 7, and then multiply it by 2. That's why I put the n plus 7 in the grouping symbols. You know there's a sense of first here too, because of course parentheses go first. Next one, the sum of 7 and twice a number. There's nothing being grouped here, so it's just 2n plus 7 or 7n plus 2. They are both correct. Next up, 4 times the sum of 3 times a number and 14. Go ahead. Okay. So 4 times the sum of 3 times a number and 14 is 4 times 3n plus 14. Good. Okay. Remember, 4 times the sum. So you have to get the sum, which is 3n plus 14, then 4 times that sum, and that's why it's grouped together. Okay, solve for the variable. You have 2 of them to do there. Go ahead, stop and start. You know the drill. Okay, so on the first one, I see a same side, same operation situation. On the left, I see h's that need to be combined. And on the right, I see numbers. So I'm now going to subtract 3h from both sides because we always want to start with the smallest number of h's. That gives me 5h minus 18 is 22. Standard 2-stepper at this point in time. Add 18 to both sides. 5h is 40. Dividing by 5, and h is equal to 8. Now let's try the next one. I notice right away that I should distribute. So I get 12k minus 15 equals 2k plus 25. Start with the smaller number of k's minus the 2k's. This is not about right and left. Start on the right, start on the left. It has nothing to do with it. It's all about the smaller number of k's. 10k minus 15 is 25. Add 15. 10k is 40. And dividing by 10k is 4. So that leaves us our procedure for solving linear equations. Are the variables on the same side or opposite side? Same side, same operation. Opposite side, opposite operation. You work toward the standard two-stepper, isolate the variables, solving the way, and then if they ask you to, check the proposed solution in the original equation. One more for you to do. Okay, so I'm going to distribute the 4 and the 2. That gives me 12n minus 16 plus 2n plus 14, and then the minus 7n is 2n plus 18. Same side, same operation on the left. Altogether, I have 7n's because 12n plus 2n is 14n, minus 7n's makes 7n's. And then negative 16 and 14 is negative 2. Start with the smallest number of n's. I get 5n minus 2 is 18, adding the 2. 5n is 20, dividing by 5, n is equal to 4. Okay, so that you can handle that equation, linear equation. You can handle pretty much anything that we're going to throw at you. Yeah, it's possible we could throw a decimal or a fraction in there, but you know what? Calculators nowadays do them anyway, so it's really not that big a deal. Now let's jump forward into literal equations. And let's have you solve, I believe there's a total of 9 questions here. Let's have you solve all 9 of these literal equations, and then I will post the answers to them. Because it's stop and stop, stop and start, this is going to take you a few minutes to do, but on my end, I'm only going to pause the video for about 5 seconds. Okay, and here are the correct answers to each of those linear equations with the work shown. The one thing I want to show you is whenever I circled it like this, I did this thing called cross multiplying, which very technically in mathematics is the product of the means is equal to the product of the extremes. And in number 14, the means are this upper right, lower left, and the extremes are the upper left, lower right. Basically, it just means cross multiply. It's the same thing. So that is how I did that work. And in the case of number 14, I put the R over 1. I did the same thing on number 20. I put the P over 1. And on number 16, I put the A over 1 for cross multiplication purposes. It's not the only way to do it, but in my experience, it's the way most students leaving high school are familiar with doing it. So, if there's any questions about this, you can just send me an email or talk to a classmate or something, okay? All right. Next up, inequalities. So you solve these 6 inequalities, and I will go through the answers to all 6 of these. Actually, you know what? Let's do them piece by piece. Let's have you do A and B first, okay? Just A and B. Okay, so letter A, we're going to add 13 to both sides. Then we're going to divide by 3, and I get n is less than 8. Now, what's the big difference between an inequality and an equation? When you're solving a linear equation, like in the previous slide, you're asking yourself, what's the one and 2 slides ago, I'm sorry. What's the one and only one answer that satisfies this equation? With an inequality, there are an infinite number of answers. So I can't just put down, say, 7, 6, and 5. I have to try to list all of them, and they won't all fit in the answer space. So I make sure with an inequality that I list all 3 parts of that inequality. The variable, the symbol, and the number. All 3 parts. If this was an equation and you just put the number 8 on the answer space, you would be marked correct. If this was an inequality, you would be marked wrong. For 2 reasons. First off, there's an infinite number of answers, not just one answer. But the second one is that 8 is not even an answer to this question. 7.999 is. 7.1, 7, 6, any negative number, 0, 2, 3, 2.5, etc. Any number that's less than 8. 8 is not less than 8, so 8's not an answer. Think of it more as a reference point. And that's why when I graph this, I put an open circle on 8 and an arrow to the left. Okay? All right. You try. Oh, we already did letter B. I subtract 2 from both sides. 7n is greater than or equal to 14. I divide by 7, and I get n is greater than or equal to 2. This time, is 2 an answer? Yes. The reason 2 is an answer to is very simple. It's this or equal to underneath. This little part of the inequality where you have the equals half or half an equal sign in there. The graph of it, because you were allowed to equal it, you can remember we fill an extra ink into the middle of the circle there. Arrow to the right, n is greater than or equal to 2. Okay, so since n is greater than or equal to 2, is 2 an answer? Yes, because you are allowed to equal it. That's very, very, very important. On the left, 8 is not an answer because there's no or equal to. On the right, 2 is an answer because there is an or equal to. All right, so now you're going to finish up letter C and then numbers 1, 2, and 3. And then I'll show you the answers to all of those. Go ahead. Again, it's just a few short seconds on my time. Okay, now, subtracting 3, multiplying by 3 because the x is being divided by 3, I get x is less than 12, and there's my graph. Notice there's no or equal to, so it's an open circle on 12. All right, a little bit later we will go over bracket notation again, so there's not any bracket notation here. Next one, subtracting the 8 from both sides, negative 3n is less than 9. Then I divide by negative 3. And this is a really important moment. It's probably the only tricky thing with inequalities. If you multiply or divide by a negative, you must remember to switch the inequality. We gave you a long-winded explanation of that earlier. So the correct answer is n is greater than negative 3. Now, I just want to mention, we've given now, I think, 3 quizzes so far. And with each quiz, I've had a student say to me, like in letter C, in a multiple choice, very similar to this, and I would ask, I would put 12 as a choice for an answer, and the student, I would say, which number is in the answer set, and I would say 8, 10, 12, I'm sorry, 10, 12, 14, 16, and students will say 12 is an answer. 12 is not an answer in letter C, because x has to be less than 12, so 10 would be the answer. Here, the n must be greater than negative 3. So it's any number bigger than negative 3, but negative 3 is not an answer. If there was a little line underneath, like in letter B, then yes, because of that or equal to line underneath, you are allowed to be greater than or equal to 2. So 2 is an answer. There is no such line in C or 1, therefore those results are not answers. It's only the things less or greater depending on the symbol. Number 2. Distributing, combining like terms to both sides, adding 17x to both sides, I get 38 is less than or equal to 24x plus 50. Subtracting the 50, this was actually the same question we did the other day, but this time I cleaned it up so that I didn't make a mistake. Dividing by 24, and I get x is, either I get negative 0.5 is less than or equal to x, or if I turn it around, which is what I want to do, I want that x on the left, x is greater than or equal to negative 0.5. But I drew the arrow in the wrong direction because it should be greater than. I don't know why I did that. So this is the ding, 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 the Lindquist Daily dumb mistake. I did it again. I'm not a big Britney Spears fan, but oops, I did it again. I should have made the arrow go to the right. Sorry about that. Okay, but I'm telling you, so you just have to take the answer verbally rather than through the image. Negative 0.5 is an answer to this because of the or equal to underneath. Number 3, minus the 5, and then x is being divided by negative 4, so I multiply it, and because I'm multiplying by negative, I have to switch the direction of the inequality. So x is greater than negative 16. There's my graph. No or equal to underneath, so it's an open circle, and negative 16 is not an answer to this question. All right, so there's some inequality solutions for you. Next up, for this first one, I would like you to express this in both interval notation and bracket notation. Go ahead. Okay. So you are allowed to equal the 0 because that's a closed circle. And this is an open circle, so you're not allowed to equal the 4. And that's why I use a bracket for the 0. Remember, the top and bottom of the bracket make an equal sign. You are allowed to equal the 0. And then a 4 is a parenthesis. And then over here, 0 less than or equal to x less than 4. The bracket means you're allowed to equal it. That's why I have the less than or equal to. And then I have the 4. You're not allowed to equal it because of the parenthesis and the open circle. I also want you to keep in mind this. This isn't a bounded interval. The ends of the bounded interval are 0 and 4. You just need to determine, anytime you have a bounded interval and you express it as in interval notation, you're always going to have a less than, your variable, and a less than. The question is, do you put a line underneath or not? And if the circle's filled in, you do. And if not, you don't. Let's have you try the next one. Go ahead. Okay, we're going to get a closed circle on 0, means you're going to have a bracket on 0, and then you're going to have an open circle on the right, so that's a parenthesis. And again, interval notation, 0 is less than or equal to x, which is less than 3. You are allowed to equal the 0, so I put the little line underneath. All right, let's have you try represent each with an inequality and bracket notation. Go ahead. This is just the first one. Make sure you have an inequality and bracket notation. Okay, so that would be n is greater than 3, right? And if we use bracket notation, you're not allowed to equal the 3, so it's a parenthesis. And it goes on forever and ever, so that's infinity. And we always have a parenthesis, whether it's positive or negative infinity. Anything that's infinity is parenthesis. For the next 4, we're just going to use bracket notation. Do each of the 4 questions. Let's do the first 2, then the second 2. So do the first 2, I'll show you the answers, then the second 2, and I'll show you those answers. Go ahead. Okay, so for the first one, they're both filled in circles, so they both get brackets, -2 to 5. For the next one, they're both open circles, so they both get parentheses, -2 to 5. Now, try the last 2. Okay. This one has a closed circle on the right, so the right side gets a bracket, an open circle on the left, so the left side gets a parenthesis. And then it reverses on the last one. The left side gets a bracket because it's filled in, and the right side gets an open circle. Okay? -2 to 5. All right. So, bracket notation. The last thing that we need to do as we review along is slope and y-intercept. Remember, the general equation of a line is y equals mx plus b. The slope is m. It's always whatever's in front of the x. When it says y equals, if it doesn't say y equals, then all bets are off. And the y-intercept is the b at the end. Now, why do we use an m for slope? Because it's how you move. Why do we use a y-intercept? B, because it's where you begin. In this graph over here, you begin, you would mark the y-intercept, and then you move according to the slope. In this case, the slope is 2. You'd go up 2 over 1. Identify the slope and the y-intercept for each of these 3 linear equations. Go ahead. Of lines. Okay, so for the first one, the slope is 4 and the y-intercept is 1. Remember, the slope is always the number in front of x. The y-intercept is the number at the end. Next up, slope is -2/5. The y-intercept is -3. And next up, the slope is -1. The y-intercept is 9. Okay. Now let's find m and b. So this time, the first thing I'd like you to do is graph this equation. And I want to call to your attention the fact that this does not say y equals. So the slope is not -6 and the y-intercept is not +6. This says 3y equals. And you must get this into the form that says y equals. Go ahead. And then graph it, of course. And remember, if you are having difficulty with graph paper, you could print it off the internet. Okay, so the first thing I notice is it says 3y equals instead of y equals, so I have to do the inverse or opposite of multiply by 3, which is divide by 3, which gives me y equals -2x plus 4, which means that the slope is -2 and the y-intercept is 4, right? -2 is in front of the x, 4 is at the end. So here's my green graph. I begin at 4, right? That's what the B stands for in y-intercept. It's where you begin. Since it's the y-intercept, you begin on the y-axis, not the x-axis. Then I go down 2 over 1. See how I can just count this, right? Down 2 over 1. Then I go down 2 over 1 again. And I could go down 2 over 1 again if I chose, or I can just play connect the dot. All right. Now, this is a simultaneous linear equation solution. So we're doing it also with this particular line. Y equals x minus 2. Go ahead. Okay, so this is already in y equals mx plus b form. The slope is 1. The y-intercept is -2. This will be the blue line that we graph. So we begin where? -2. So I make my mark on -2. Now, I'm going to go slope up 1 over 1, up 1 over 1. And just to show you, you don't have to just go up 1 over 1. Anything that reduces to 1 over 1. So I'm going to go up 3 and over 3. See, here we go. Up 3 over 3. 3 over 3 reduces to 1 over 1, just like 1 is 1 over 1. So if you just, whether you do 3 over 3 or 1 over 1, you get the same line. It works either way. Again, some of the consistencies of mathematics that I really appreciate. Now, this is an extremely important point right here because it's both green and blue. The green line is a picture of every point that checks or works or satisfies the equation that's green. Likewise, the blue points are the points that satisfy all the equation that's in blue. The one point that's both green and blue is a very important point because it's the solution, the simultaneous solution to both equations at the same time. And they pass or intersect at the point 2, 0. So that's the correct solution. Okay? All right, let's have you try another one here. A little less explanation by me. Just remember, get things in y equals mx plus b form if they are not there already. Go ahead. Okay, so to get this in y equals form, I add 2 to both sides. Y equals -2x plus 2. That means the slope is -2. The y-intercept is 2. I begin at 2, so my green line begins at 2. Now my slope is -2, so I'm going to go down 2 over 1. Down 2 over 1. Connect the dot. There's my line. Next up, you graph this one. Okay, so the problem with this one is it says 3y equals. We need to make it say y equals, so I divide everything by 3. That gives me a slope of 2/3, right? Because it's a 2/3 in front of the x, and the y-intercept at the end is -3. So I begin the blue line by touching at -3, which I don't know why I began at -5. Let's go back and let's change this. Okay? Not at all. This is going to become a -15, and then this will become a -5. Of course, include a little bit of a sound mathematical principle here. All right, green graph, done. Okay, dividing by 3, which we did before. There's my slope of 2/3, y-intercept of -5. And there's my y-intercept of -5. So this puts us in the place to begin. Okay, so what I want you to notice here is it would have begun at -3. Now it's going to begin at -5. So basically, whatever graph you drew is just going to move down 2 places each of the ways. Now, if you notice, the slope is up 3 over 2. Up 3 over 2. Oh, man. I made another mistake. I'll do a new video. We're not going to meet at a perfect point this time. That's what this means. Up 2 over 3. Up 2 over 3. Up 2 over 3. And unfortunately, as I said, we're not going to meet at a perfect point. So we won't have a common solution here that's a normal point. So I do apologize about that. Okay, so let's just sure as heck that I get this right the next time. I don't know how I made these errors. I apologize. But now we are at the correct solution time. Okay, ready? The slope is 2/3, the y-intercept is -5. So I begin at -5, and then I'm going to go up 2 over 3. Up 2 over 3. Up 2 over 3. And connect the dot. And unfortunately this time it doesn't work out on a perfect point. And I guess there's a teachable moment here too, because if you noticed on the others I said, oh, it's always comforting when it ends up on a perfect point. This does not end up on a perfect point. Now, in real life, things rarely work out to be perfect points. But in math class, they usually do. So I'm not going to check anything or mark exactly what the point is. We're just going to leave it at that. Okay? I will tell you that today we're going to talk about algebraic solutions. And the algebraic solution to this would be a lot easier to figure out because algebra works much better when points are not perfect. All right, so you're going to graph these 2 lines. I already give them to you in y= form. So go ahead, graph both lines, find that point of intersection where they cross. All the way through both lines. Okay, so slope is 3. The y-intercept is -1 for the first one. Remember, y equals mx plus b. M is the number in front of the x. That's the slope. It's how you move. And the y-intercept is -1. We mentioned the other day that 3 is really 3 over 1. So when you move, you got to go 1 over. Next one, the slope is -2. The y-intercept is -6. The first line will be done in red. The second line will be done in green. So I begin at -1. Then I move up 3 because the slope is 3. So I'm going to move up 3 over 1. Then again, up 3 over 1, and then up 3 over 1 again. And look at that, I end up there. There's all my 3 over 1s. And connect the dot, there's my line drawn. Now for the green line, I begin at -6, okay? And then I go down to, the slope is -2, so I go down 2 over 1. Now, going down 2 over 1 is the same exact thing as going up 2 and then left 1. Can you see that that would draw the same line? Down 2 over 1 this way, we're getting that same line formed. So normally we go, when you see a slope of -2, it's down and then over to the right, down and over to the right. But in this problem, we would be running out of room, okay? So, because we would be running out of room, we just say, okay, well, you know what? I'll go the other direction. Instead of going down and to the right, I'm going to go up and to the left. If you notice, when you go down and to the right, one's negative, one's positive, and when you do a negative divided by a positive, you get a negative, so the slope is negative. That's what you want. Likewise, if you go up, which is positive, and then left, which is negative, you still get a positive divided by a negative. So that's why the slopes are equal. And we connect the dot right there. And again, notice, this time we don't end up on a perfect point either. And it's in situations like this where we do not end up on a perfect point. It's really close to perfect, okay? It's just that we're off a little bit with the red graph. It's actually going to meet perfectly on the point -1, -4. Okay? In the case that they do not end up on a perfect point, that is where algebra comes into play. Now, occasionally they ask you to check your solutions in one of these simultaneous graphs. In the red line, I plug in the points -1, -4, and I see that it checks, and in the green line also. For me, it's important to check something like this because the red line and the blue line are just slightly off, and it makes it look like it's not going through exactly the point -1, -4, so I had to check it. All right, so that covers everything that we reviewed up until now. There's nothing new in that work. The next video will be the new work.